Hi, so today we will be working on page 21 of your Ready book. And again, if you don't have your Ready book yet, just write your notes on notebook paper until you can get one. So quick little review from yesterday. So remember that translations change your X or your Y value by moving it right or left will change your X value, and moving up or down will move your Y value. So if you go to the right, then you are adding to your X value. If you move to the left, you are subtracting from your X value. If you move up, you're adding to your Y value. And if you move down, you're subtracting. So for example, we have our A here, so our X coordinate is 4, because remember our X always comes first. So we have 4, 8. So then we are subtracting, we are moving 5 units to the left, so we are subtracting from our X value. So we take each of our X coordinates and subtract 5 from them to get our new of A prime, B prime, and C prime. So now for this problem, we have developed performing a reflection in the coordinate plane. So Alyssa is making a paper dragon puppet as part of her family's Chinese New Year celebration. She lays her tissue paper over the coordinate plane like so, where she draws this figure here to make one of its eyes. She wants to make another eye by reflecting it. So today we're talking about reflection across from the x-axis to form our new figure of w prime, x prime, y prime, and z prime. So we need to figure out what are those coordinates. So I'll go ahead and just play this video here. Video within a video.
Alright, so right now we have Alyssa is making a paper dragon and she wants to reflect the figure across the x-axis. So this right here, which therefore means that our line of reflection is going to be our x-axis, so this line here. That means that each point needs to be equal distance from the line of reflection of our new figure and our old figure. So our y is 1 point away, so we have to go 1 point away here. Our z is 1, 2, 3 points away, so we'll go 3 points away. 1, 2, 3 here. Our w is 1, 2, 3, 4 points away, so again we go 1, 2, 3, 4 points here. Our x is 1, 2, 3, 4 points away, so again we go 1, 2, 3, 4 here. And from there we just draw the line to connect it so that we have our new figure after it has been reflected over the x-axis.
Okay, so that's how you do that problem. Nope, let me just replay. So now we have the picture it. So you can draw the image in the coordinate plane. So we drew it right here. And we need to find the identify the coordinates of the vertices of our new image. So our w prime is now -3, -3, -4. So -3 for our x, -4 for our y. Our x prime here is now -1, -4. So our y prime we see is now -2, -1. And our z prime is now -4 for our x, and then we go down -1, 2, so -3. So there's our new vertices after we reflect it across the x-axis. So now we're at the connected part. So we're going to use that problem from the previous page to help us understand how to perform it in a coordinate plane. So when we look at the picture, we want to see how does the distance of each vertex of figure wxyz to the line of reflection compared to the distance of its corresponding vertex, so the one that aligns with it. So like w and w prime match together, or x and x prime match together, etc. Then we're going to look at the model it for what are the coordinates of y prime and z prime to complete the table. So each vertex of the image is the same distance from the line of reflection as this corresponding vertex. So if one is 3 away from the line of reflection, it's going to be 3 the opposite way. And that depends on the line of reflection. So for this example, we used our x as our line of reflection. So if we're 3 up, that means we'd be 3 down. If you have your y as your line of reflection, if you're 2 to the left, then you'll be 2 to the right. And then again, we already found that our y vertex is -2, -1, and our z vertex is -4, -3. So the table shows how the coordinates of a point change when it's reflected across either the x-axis, so again that's this one, or the y-axis, this one. So I'm going to describe how they change. So if our original point is 2, 3, when it's reflected across the x-axis, we have 2, -3. So your y value becomes its opposite. If we reflect over the y-axis, your x value becomes the opposite and your y value stays the same. And that will be the same for all of these. So when you reflect across the x-axis, your x coordinates stay the same and your y values become their opposite. So if it was positive, it will be negative, and if it was negative, it will be positive. If you reflect across the y-axis, then your y values stay the same and your x coordinates become their opposite. So again, your x coordinates, if you reflect across the y-axis, if they were positive, they will become negative, and if they were negative, they become positive. So, what are the coordinates of the point xy when it's reflected across the x-axis, when it is reflected across the y-axis? So when you have xy and you're reflected across the x-axis, x stays the same and your y becomes its negative because you are flipping it up or down. When you reflect across the y-axis, your x value becomes its opposite and the y stays the same because you are flipping it right or left. So again, y-axis, you go left to right or right to left. X-axis, you're going up to down or down to up. So now we're going to do this problem here. So Seth has this triangle ABC that he is reflecting across the x-axis to form a new triangle DEF. We want to draw that and then label the coordinates as so. So again, I'll just show this video real quick. Alright, so we see that Seth reflected triangle ABC across the x-axis to form triangle DEF. We need to draw the new triangle and then find the coordinates. So again, it's across the x-axis, so we will use this one right here, or x-axis. And then, so A is 2 away from our line of reflection. So from here we go up 1, 2. So there's our new point. Then we have this B here, which is 2 away, so we go up 2, so we have that point there. Then C is 1, 2, 3, 4 away, so we go 1, 2, 3, 4. And we have our new triangle here, with this being C, this being F, and this being. From here we need to get the coordinates. So for D, remember x value always comes first. So we have 1, and then it's up 2. And then for E, remember x value always comes first, which is at point 3. So we have 3, and then it is up 2. Lastly, we have point F. Remember, x value still comes first, so that's 3. And then our y value is 4.
So that is reflecting across an x-axis.
So that's how you do that problem there. So now Isabella is planning to a design that uses different colored wooden triangles. So she has this triangle here, this JKL, and she wants to reflect it again across the x-axis here to draw a new triangle of J prime, K prime, L prime. And she wants to draw it in the coordinate plane with this as our line of reflection. So we need to figure out what are the coordinates of the vertices of J prime, K prime, and L prime.
Alright, so we are going to be looking at this right here. So our question says that Isabella is planning a design that uses different colored wooden triangles. She starts by having this triangle in the coordinate plane. She wants to reflect it across the x-axis to form the triangle of J prime, K prime, L prime. So we want to draw it and then find the coordinates. So first we are reflecting across the x-axis, so that's this one right here. And so that means that it's equal distance from that line of reflection. So we have our L is the same point, so it's going to stay on the line of reflection right here. That would be our L prime. We have our J, just 2 away, so we go down 2 right here for J prime. We have our K, which is 2, 3, 4 away, so 1, 2, 3, 4 right here for our K prime. And then finally we just connect the dots to form the triangle. So there's our reflected image. And now it's asking for what the coordinates are for our new figure here. So we can see that our J prime is equal to 0. We always have our x value first. 0, -2. You see that our K prime equal to 4, -4. And finally, our L prime is equal to 4, 0. Again, our x values always come first when we have our ordered pairs.
Okay, so that's how you do that problem. Then our last one says that Malik draws quadrilateral STUV in a coordinate plane that has these vertices. So this time we have to go based on the number and we can't look at it. So then, and he reflects across the y-axis to form quadrilateral. What are the coordinates? So remember, this is when the whole opposites come in handy. So again, there's going to be a video right here for me to show.
Alright, so for this problem, we see that Malik draws the quadrilateral STUV in the coordinate plane with vertices of S of -5, -4, T is -4, -1, U is -1, 0, and V is -3, -3. And he wants to reflect it over the y-axis. So when you reflect something over the y-axis, the x's change and the y's stay the same. So again, when you reflect over the y value, when you reflect over the y-axis, your x values change and your y values stay the same. Meanwhile, on the reverse, if you were to reflect over the x-axis, your x values would stay the same and your y would change. So this problem, we are reflecting over the y-axis, so our y values stay the same and our x values become their opposites. So we have here is our s, which we see is at -5, -4. So if we were to, again, we have to keep our, make our x values the opposite. So the opposite of -5 is +5, and we keep our y values the same, so -4. Here we have t. Sorry. Okay. Anyways, we have t, which is at -4, -1. Again, if we want to make the new t, so t prime, that's going to become the opposite of -4, so +4, and then we keep our y values the same. So remember, these are all for the new figures, so they're all prime. For u here, we have the values of -1, 0. That means that it's going to become our opposite for our u prime. So the opposite of -1, +1, and then our y values stay the same. And finally for v, we have -3, -3. Remember, our x values change, but our y values stay the same. So our -3 becomes the opposite, which is +3, and then our y value stays the same as -3. So then that would be your solution right here.
So that's how you do that problem. So again, that's when you reflect over the y-axis. And also my sniffling was because my allergies were acting up. So, all right, little reflection. Make sure you write this down somewhere. This is probably the most important part of the lesson today. So remember that when you reflect along the x-axis, your x coordinates, so that first number is going to stay the same, and your y coordinates will become their opposite. So again, if it's positive, it's negative. Then if it was negative, it becomes positive. When you reflect across the y-axis, your y coordinates stay the same, so that's that second number of the ordered pair, and your x coordinates become their opposites. If they were positive, they're now negative, and if they're negative, they're now positive. So make sure you write this down. If you need to pause the video, do so. Just make sure that this is written down somewhere. Lastly, your homework is going to be those pages 25 and 26 in your Ready workbook. They're going to be due tomorrow at 9 a.m. per usual. And again, if you don't have the Ready workbook, there is a PDF version available that you can use.